Okay, this is for section 1.3, and this is on distance and midpoint. Okay, and these you should have covered in Algebra 1, so it should be some review. First on distance. Okay, distance is between 2 points or ordered pairs. And we're going to go through the distance between 2 points. Separate your paper here in half. Okay, and let's look at if you have 2 points on a number line. Okay, on a number line, and let's label that there's a point P right here, and then go 1, 2, 3, 4, 5. Put another point Q. Okay, and let's say this is represented, A is 5 and B is 20. Okay, and if I want the distance from P to Q, okay, it is the absolute value of B minus A. Okay, so you're going to substitute in B was 20 and A was 5. Distance is always the absolute value. It's always going to be positive. So it's the absolute value of 15. So the distance between P and Q is 15 units. Okay. If you did it the other way, from let's do it the other way. Q to P. Okay. If you did it the other way, you're still going to end up with 20 minus 5, or 5, well, you could go the other way, 5 minus 20, and took the absolute value of negative 15. I might have reversed these letters, but you're still going to end up with 15 both times, because the absolute value of 15 is the same thing as the absolute value of negative 15. Okay? On a coordinate plane, if you have two ordered pairs, x sub 1, y sub 1, that ordered pair, and the ordered pair x sub 2, y sub 2. Okay? You can do it by the Pythagorean theorem, and I'll do that in a minute. But most of the time, you're going to use the distance formula. The distance formula is, okay, please do it in this order. It's x sub 2 minus x sub 1. Those are subscripts. This is not x sub 2. This is x sub 2. Write it with a subscript. Quantity squared and a plus sign in between, and y sub 2 minus y sub 1, quantity squared. And that square root should go out over all of it. Okay? Extend it out over all of it. And then basically you just sub in. You would write your whatever they give you for your ordered pairs. You sub those in. You simplify it out, okay, and get your answer. Okay? I'm a huge stickler because I teach all the way up through calc. I know what you need to do. Okay, I'm a huge stickler for write the formula down, sub in, simplify and get your answer. So, like a lot of times when I'm grading, I'm not just grading this. I'm grading this, and I'm grading this. Okay? Write the formula down, sub in, simplify. Okay, let's look at a couple of examples. Okay, and I use EX for example. Say they ask you to find the distance RT. Okay, and over here on a picture, okay, R, they have -4, and that's A. And T is 2, and that's B in our formula. It's always alphabetical in the formula. So RT is the absolute value of A minus B. and it's negative 4 minus 2. Okay? So that would be, what's negative 4 minus 2? Negative 6, and the absolute value of negative 6 is 6. So the distance from R to T would be 6. What would be really handy for your grader is if you circle it, double underline it, highlight it, something for your grader so they can tell what your final answer is. Okay? I haven't taken any data grades yet, but I'll be honest with you, I'm getting close. So show your work and number it and help your grader out. Say they ask you to find the distance between, and on the paper you don't have to write out the directions on your homework. I'm writing it out so you know what kind of problems that you'll end up with. But let's say you had negative 4, 1, and point F is 3, negative 1. And I'm going to label this one is my x sub 1, y sub 1, and this one is my x sub 2, y sub 2. What you could switch that around. Like I could label this one x sub 2, y sub 2, and this one x sub 1, y sub 1. What you can't do is you can't do x sub 1, y sub 2. That doesn't work. Okay? Okay, now I'm a huge stickler for this. Write the formula down. That square root extended all the way out. X sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. Okay, now you sub in. Okay, my x sub 2 is 3 minus my x sub 1 is negative 4 quantity squared plus my y sub 2 is negative 1 minus my y sub 1 is 1. Okay, now you simplify. What's minus a negative? Same thing as a positive. So that's like 3 plus 4 would be 7 squared. Negative 1 minus 1. Think about a number line. You're at negative 1 and you subtract 1. Negative 2 squared. Okay? And then you got 7 squared, 49. Negative 2 squared would be 4. And by the way, if you do this on a number line, on our calculator, negative 2 squared, you're going to get the wrong answer. Because the author is doing order of operations, or the calculator is. If you want negative 2 squared on the calculator, you got to put it in parentheses. It's doing a negative 1 and then 2 squared. Okay? Okay, and you end up with the square root of 53. So the distance. Now, here's one thing too. You see those equal signs all the way down? You don't have to write the D down on every line, but it ought to be on the first line and the last line. Okay? And then you get here? 7. Here? Yeah, x sub 2 is 3. And my x sub 1 is negative 4. Make sense? I'm just subbing in. Okay. Now, those of you, you're going for the perfect grade on your test, you would want to check this. So you'd go on your graph paper and you would graph E is negative 4 and up 1. And it's negative 4, 1. F is 3 and down 1. And you want to know what's this distance. Okay, so you do a vertical line and you do a horizontal line through there. Should have gone through that line. Okay, and do Pythagorean theorem, right? You've done a squared plus b squared equals c squared. Okay, my a, like I've got 2 spaces here from here to here, and I've got 1, 2, 3, 4, 5, 6, 7 from there to there. So it'd be 2 squared plus 7 squared equals c squared. 4 plus 49 equals c squared. 53 equals c squared. Take the square root of both sides, then c equals the square root of 53. Your answer ought to be the same whether you do it Pythagorean theorem on a graph or do it the distance formula. Okay? Okay, put a little separator there. We're only going to get through part of this. Okay, the next thing is midpoint. Midpoint means that it's in the middle. So you're going to add them together and divide by 2. So midpoint. Separate it a little bit. Okay, on a number line. Okay. Say this is point P. This is point Q. The midpoint is the one that's right in the middle. And this would be A and this would be B. So the midpoint, you add the A and the B together and divide by 2. Don't make that hard. If you're on a coordinate plane, where you have, if you're on a coordinate plane, you'll be given 2 ordered pairs. So they'll give you an x sub 1 and a y sub 1 and an x sub 2 and a y sub 2. That just tells you got 2 separate ordered pairs. Here's the formula. And you'll write the formula down every time they ask you to find midpoint. Okay, you add the x's together and divide by 2. You add the y's together and divide by 2. Then that should be the one in the middle. Okay? Okay, let's look at an example. Say I'm on a number line here, or graph. Okay, and I've got, okay, and let's say this is point A, and it is 7. This is point B, and this B value is, oh, I drew this in the wrong order. Sorry, my picture's backwards. Okay. Add them together and divide by 2. Add them together and divide by 2. So it'd be -8 over 2 would be -4. Okay, let's say I give you 2 ordered pairs over here. Point A is -2, 3. And point B is -8, -9. Okay, write the formula down first. X sub 1 plus x sub 2 divided by 2. Y sub 1 plus y sub 2 divided by 2. I'm going to label this one my x sub 1, y sub 1. This one my x sub 2, y sub 2. So now just add the 2 x's together. So it'd be -2 plus a -8 over 2. There's a comma in between. Add the y's. 3 plus a -9 and divide by 2. -2 plus a -8. -10 divided by 2 be -5. 3 plus a -9. -6 divided by 2 would be -3. So your midpoint is 5, -3. Now, sometimes they give you these 2 ordered pairs. Sometimes they'll give you the midpoint. If they give you the midpoint over here, then the first x value on the midpoint has to equal this. And the y value has to equal this. So you're going to have to separate it and work 2 separate equations. Okay, that basically is distance and midpoint.